Mic check 1 2. Okay, we are streaming, we are live. Camera angles all good? How's all the camera angles? I'm going to change that one. I'm going to change that A shortcut to the other one. Hey Chris, how's it going, buddy? Yeah, what's up? So, I've rearranged some of my cameras. So they're a different way around now. So you can only see the chat because I've moved my cameras around, but I haven't changed around my OBS stuff. I've ordered a couple of new cameras, so because I wanted to get my good quality camera on the scope, which is up there at the moment. So you can see now, if I do this, the scope cam looks a lot better. It's a much higher quality and it's much faster response. It used to be a really crappy camera and so it didn't respond very quickly, but now you can see it's very responsive and it looks pretty good. So yeah, let's wait for a couple more people to jump on the stream and I'll talk through what's going on. I'm wondering whether Nicholas is going to jump on tonight. That'd be good if Nicholas jumps on. Yeah, look, if I touch the probe, it's a triangle wave. 50 hertz triangle wave. See, now you guys can actually see, I think, hopefully you can actually see the numbers. So you can see there that it's 50 hertz. And, yeah. The voltage, etc. So if I touch the probe, we've got 2.3 volts worth of 50 hertz. And if I remove my feet from the floor, it bumps like that because I'm grounding myself differently if I remove my feet from the floor. Yes. Okay. So sorry for you guys there waiting. I'm just gonna wait for a couple more people to jump on the stream. Oh no, video output low. Why? How? Apparently my stream is bad at the minute. Hey Jesse! Yeah! Okay, apparently 1/2 No, why is stream output low? This is not what I want to see. Whew. Okay, I think that's fixed it. I think it's better now. Beerman and Daniel and Josh and Jesse, how's it going? I'd love Nicholas to jump on at this point because I think he would have some advice for me. I noticed, I found out why this ground zero keeps blowing the FETs that I put in. So if you were on my stream the other night, what was it? Last night? Yeah, I think it was last night. We've been trying to fix this ground 10K, and every time that I powered up, it absolutely obliterates like 1 or 2 or more FETs in the output section. It explodes them really badly and it looks very, very cool while doing so. If I actually jump on, I'm going to jump onto my documents here. I'm going to show you the video. Wait, how can I do this? Window capture. What's it window capturing? No, it's not window capturing that. 1 minute. If I get rid of that, turn on front Logitech, and then I am going to show you the videos from last night if you missed it, of stuff exploding. So if yeah, here we go. Open with VLC. Desktop audio, turn on my desktop audio. Wait for VLC to open. Here we go. Alright. Whoa! I'm just going to add window capture to this for VLC, window capture 2, VLC, there we go. Okay, so now hopefully you guys can see my VLC player in the window here. So if I go back on VLC and play that from the beginning. Why don't I have any they're all the way down at the bottom. Damn, okay. That's better, there we go. Okay, make this a bit bigger. Okay, there we go. That looks about right. That'll do. What's happening, people? All right. So this is what happened the other night, last night. Actually, this is also what happened today. So this is with the amplifier has 4 FETs in the output section, 1 per bank, and yeah, whoa.mp4. And this is what I was dealing with earlier today. So if I go ahead and hit play, hopefully you guys can hear what's going on here. Whoa! It's just stuttering. Whoa! Nah, it's stuttering like crazy. Why is it stuttering like crazy? One sec. Let me try and close some stuff. Maybe if I make this smaller, maybe. And just enlarge it here so the quality is really crappy, but oh well. Never mind. Whoa! There we go. So can you guys see that? Is that working for you guys? Can you see that shit explode like crazy? Let me know in the live chat. Yeah, let me know in the live chat if you can actually see that explode. I've not got anything coming through in the live chat at the minute. Is my internet even working? Okay, stuff coming through on the live chat now. Well, they're not related to what I'm doing. Are the gate resistors in spec? Is the output driver IC working right? Got bass in my truck now. 4 amps on. Oh yeah, cool. 4 amps on the healing bench to fix this week. Need more streamers to keep me working. No worries. H1 Nick was talking about Zen diode. Yeah. So, what's interesting is I have found the problem. Well, I found the source of the problem that's causing these FETs to explode like that. Let's watch that one more time because that's Bosh. Whoa! Yeah, so that's the issue that we're looking to try and find. So I found what's causing that issue. And what's causing that issue is this. If I open up this other video file I've got here. Whoa! Open VLC. Whoa! Those are building to the exact same level, and then the drive builds in, as you can see here, which is, and then it tapers off. I've got no FETs. Continue driving. So the difference in voltage between these two is about, actually it's about 10 volts. So if I now remove the remote, Watch what happens to the gate probe, the line that's above. It suddenly, instantly bounces to the negative rail, and that will be turning the FET on fully. As soon as I remove the remote, the top line goes boom, straight and bounces. It bounces to the negative rail first, then comes back and then slowly goes towards it. It's very strange indeed. We can see that there's about 10 volts there worth of difference, and as soon as I remove the remote, it goes to 0, and then there's no difference between the two. That one of them will bounce considerably low. Bosh. That is the issue. Okay, so hopefully you guys saw that. That was just a little pre-recording I did earlier today. So the issue is that the gate, so when I remove the remote, the gate's drive is bumping to the negative rail for a split second, which is causing all the FETs to turn on, and I think it's dumping that power through this small resistor here. So you saw yesterday on the live stream there was a resistor that was reaching a very, very high temperature when I kept pulsing the amplifier on, off, and it was this resistor over here by the output, by the speaker terminals. Now what I'm going to try, I believe the issue may be somewhere on the driver board. I checked to see where that little pulse on the gate drive was coming from, and it's actually coming from before the driver IC. So that little pulse is there on the logic input of the drive IC chip itself. So the issue isn't a Zener diode on the outputs. It's not a bootstrap issue. It's not any snubber circuit issues or anything like that. The issue I believe is on the driver board before the drive IC, before the IRS21844S. So I'm going to be looking at issues with the 072C, the 072C, the 211, and the LM37 something. There's another chip on there as well. I can't remember the name of it as well. And also looking at issues with the A92 small transistors on the driver board as well. So I think we're going to have to pull the driver board out again and change some stuff on the driver board, because I believe the issue is coming from the drive circuit before it reaches the IC chip. So, but one thing I'm going to try before I do that, I was going to try this just on my own. I wasn't even going to bother live streaming tonight, but I thought maybe some of you guys would be interested to see it. You never know. So I'm just kind of live streaming my own experiments just now. So what I was going to do is I was going to hook up a speaker load. Okay, so if we go down here, get this bulb out of the way. Get out of here. So I was going to hook up a speaker load, so a dummy load here, to the speaker terminals. And then what that should do is that should dump that voltage spike to ground. Rather than letting the FETs deal with that voltage spike, it's going to ground it. And what I want to do is I want to probe the positive speaker terminal and see how bad the voltage spike is, and whether a subwoofer would actually play it, or whether it would just get sucked up and disappear without being heard through the subwoofer. So I'm gonna, for fuck's sake, I need to widen that up a little bit. And stick it in here like Tony Blair. Stick it in there like Tony Blair. Okay, so there we go. I'm not going to bother doing it up. So the dummy load is attached to the speaker terminals now. So I have got 4 FETs fitted like we had before, and I'm going to power her up, and hopefully this time, rather than the FETs having a voltage spike, it'll dissipate through the load instead of letting the FETs have to deal with it. This is kind of my thought process anyway. Hopefully not. The FETs I've loaded up, they are all different batches, right? So usually you have to put the same batch in each parallel bank. So that would be this bank, this bank, this bank, and this bank. So you could technically have 4 different batch FETs in each of these 4 banks. Now, because I am quite positive that these may explode, I'm using odd FETs that I've got that don't have any partners. So obviously these single FETs I can never use in a parallel bank, so I can never ever use in an amplifier repair. They're just random odd FETs I've got, so I don't care too much if these explode because I couldn't use them anyway. So all I'm doing is I'm just using them for a quick test. I'm going to power the amplifier up for a couple of seconds on like 9 volts worth of input, which you can actually now see. I've got 9 volts up here. And then I'm going to turn the remote off and we're going to see, do the FETs still explode, or do they actually work and not explode because they're dumping the voltage through the dummy loads rather than the FETs having to deal with the grunt of it. So let us see what the jam is. So I'm going to have to cover my eyes again and cover my ears because the bang is very loud indeed. And I'm going to take my oscilloscope probes, and we're going to probe the high side and the low side so we can see what happens. So if I probe the low side drive and then the high side rail, because that's something we want to see. We want to see the high side rail. So yeah, we're 50 volts divided now, and yeah, I think we are good to apply some remote signal and see what happens. So you can see the two on the scope screen there. Which is that side. You can see the two voltages getting further away from each other, and so what we're measuring here is we're measuring the low side drive and the high side rail. I'm just going to zoom in a little bit so we can see the drive waves when they appear. Now it's time for me to cover my eyes and cover my ears, and hopefully this does not explode. Okay, so we have switching. I'm going to turn it off now. Alright, well nothing exploded, but it did something really weird on the scope there. Did you see? The drive actually stopped. Now, why did the drive stop? It stopped almost like it didn't have any FETs in the board, which is very strange. And there seems to now be, well, the low voltage rail is actually sinking down very quickly. So I wonder whether one of these FETs was actually did just die and is now no longer a FET and is just leaking. That's interesting. I'm going to try and power it up again, and if there's some issue then it will just explode. No worries. Well, like, it comes on, but it doesn't seem to stay on, does it? Look. Whoa, as soon as the relay clicks in, do you see? As soon as the relay clicks in, both of these rails were like shooting up towards the top. And these FETs are now starting to heat up. Well, one of them is anyway. This is some weird shit going on, and this wasn't happening earlier at all. I wonder if that's got anything to do with me having the speaker load attached. That's weird. Never seen that. Never seen that happen earlier. Okay, let's do this again. This time I'm gonna, because I don't think they're gonna explode, I'm gonna change the camera angle so you guys can see the scope, which is this one, so you can see exactly what's going on here. Okay, you ready? Relay clicks in. Whoa, as soon as the relay clicks in, both of the rails shoot up really high. I don't know why. I don't understand that. What's going on there? Why is it doing that? Oh man, that's weird as fuck. Yeah, there's something fucking very weird going on here. Okay, why would the relay clicking in make any difference? The only reason the relay clicking in would make any difference would it be if there's something going on with the speaker load here. So if I remove my oscilloscope probe from it here, I'm just gonna measure the what am I gonna do? Let's measure the high side drive so we can see the nice square wave. And I'm then also going to probe the positive speaker output. And the positive speaker output, I believe, is this middle one here. Negative rail goes lower, positive rail goes high. Yeah, they both move together. It's really weird. They both go up, so the voltage shifts up, both together, and it goes into protection. Okay, so I'm going to probe the positive speaker output. We're going to see what the positive speaker output is doing. I'm going to actually keep this probed on the low side drive this time. Okay, so nothing on the speaker terminal. Whoa. Okay, so this, for some reason, the speaker, there's negative DC voltage on the speaker terminals. That's interesting. I wonder why that is. There wasn't negative DC on the speaker terminals before. I wonder whether one of these FETs has just died. What's going on? I wonder whether one of these FETs has just died and it's no longer a FET, it's now some weird diode. So I'm going to remove all 4 of these FETs, I'm going to measure them on the transistor tester and see what the jam is, see what they're saying. The only time that I usually see the rails exceed where they're supposed to go is if the output inductors are acting like a flyback transformer. You see that sometimes if one of the sides of outputs fails, then one of the rails or one of the inductors, the way that it's driving the inductors, will actually act like a flyback transformer, and it'll increase the rail voltage until something explodes. What's going on in the live chat? Ever heard of the Omega 40K sub? Yeah, of course I have. Everyone has heard of that. Prince says I've been following offline. Oh, that's annoying. Because that means you probably miss out on a lot of stuff because the streams are always unlisted after I finish. Unless you click the link in the email you get, I think then you can watch the stream even though it's unlisted. Okay, so I'm just waiting for the rail voltages to sink back down to a safe level for me to begin soldering. So we're still at 36 volts, so I'm going to take my things here. I'm just going to short out these rectifiers so that I can start work on this jam. Right, there we go. Short it out. Nice, nice. Voice call on the sub is made from oh, what's it called? The material of the voice call on the Omega 40K is a superconductive material, and it's one of the first materials to actually exhibit superconductive qualities or properties at room temperature. So if you're unaware of what a superconductor is or superconductive qualities, a superconductor is a material that that contains zero electrical resistance, absolutely no electrical resistance whatsoever. And usually superconductive materials were only able to express those properties at very low temperatures, almost like at absolute zero for a while, and then they've slowly been progressing and getting higher in temperature. But you usually still need liquid nitrogen around the material in order for it to exhibit superconductive properties. Now, obviously, the best thing with having a material that doesn't have any electrical resistance is that you get no voltage drop across that piece of material, and you get no heat either. So you can have a wire strand as thin as a human hair that can pass 1 million watts through, or 1 million amps through this piece of thing, because it has no resistance, so it doesn't heat up, it doesn't blow like a fuse, there's no voltage drop across it. So you can literally use like doorbell wire, if it was made from this superconducting material, as your power cable to run your 1000 watt RMS system in your car. Now obviously the Omega 40K sub uses a material which is superconductive at room temperature, and so this has 0 ohms. The Omega 40K is a 0 ohm subwoofer, so you need your amplifier that you need to run on this subwoofer also has to be a superconductive amplifier, because the FETs and everything in the amplifier need to be able to drive a 0 ohm load, so they need to exhibit 0 resistance either. Now the Omega 40K, although it has a 0 ohm DC static resistance, it will still generate impedance rise, so there will still be the amplifier will still be playing like a 1, 2, 3, 4 ohm load once the woofer gets moving. But it's a good idea to have the proper superconductive amplifier as well that can drive the subwoofer properly without any risk of damage if the subwoofer presented an ohm load that was low enough to damage the amplifier. But you could technically run a good 1 ohm stable or 0.5 stable amplifier on the Omega 40K with a 0 ohm coil, and there wouldn't be any problems at all, probably. But yeah. So yeah, it's fucking cool. You can literally, the Omega 40K has an infinite power rating, because the voice coil does not get hot because it has no resistance. So the only power handling issues that you're going to have with the Omega 40K is in mechanical limits. So obviously the more power you drive to it, the more it's going to move and it's going to rip itself apart eventually with excess power. But if you can keep the cone still, put a massive port load on it, or a big sixth order with both ports tuned to the same value so it holds the cone still, you can drive like hundreds of thousands of watts into the coil and it will never blow, because it is superconductive. So how many people believe that, and how many people realized that it was obviously a complete troll that doesn't exist? That's totally not a thing. Where in the UK are you from? I'm from Southeast London. Why has this cap label been removed? I don't know. It came like that. This cap was already like this. It's just, I think it's been peeled off somehow. Something scraped against it. It's come off. The cap itself is fine though. That made my head hurt. Yeah, made my head hurt trying to explain that bullshit as well. All of what I just said about that bullshit sub that doesn't exist is potentially viable. That might become a thing, because superconductive materials do exist and they do exhibit 0 electrical resistance. I wonder what would happen if you created a coil wind using this superconductive material. Would it? Well, I would have thought it would induce a magnetic field still, but I don't know. I don't know if anyone's ever tried winding a coil made out of superconductive material and then cooling it so that it exhibits those properties. I don't know whether that has ever been done before. So I don't know whether it would still induce a magnetic field and it would still repel and attract against a static magnet. No idea. But technically, if it did induce a magnetic field, then you could potentially run a subwoofer that never blew, because the coil would never get hot. So yeah, what was I doing? Oh yes, waiting for the, yes. Let's remove those FETs because I think one of them's duff. So with this amplifier, I have this nice big batch of new FETs ready to go in. Now, the other night when we were looking at this, I had some 24N40s installed, which are too low voltage, with a 14.8 volt input into this amplifier. The rail voltages exceed 200 volts. So when you've got rail voltages that are plus and minus 200 volts, the difference between those two rails is obviously the voltage rating that the transistor needs to be able to handle. So the 24N40s are 400 volt FETs. So if you've got 205 volts on each rail, that's going to be 410 volts, which is higher than the FETs maximum. So this amplifier needs 500 volt parts, 500 volt FETs. So at the moment I've got some 20N50s. Now, I wonder whether... So obviously there's an issue when this amplifier turns off. There's a voltage spike which causes the FETs to blow. I wonder whether loading all 6 FETs into each bank will mean that there's enough grouped together that they will all handle the voltage spike okay, and they won't die from it. And then I can continue to troubleshoot with all the FETs in the board, knowing that they're not going to kill themselves from a voltage spike. But I don't know, like this here, this is like £25 or like this is like $32 worth of FETs. So if these all blow, then I've lost like $32 worth of FETs, and I don't really want to do that, of course. So no, hang on, how much? No, hang on, 60. No, this is more like $45 worth of FETs. Yeah, it's more like $45 worth of FETs there. Alright, so I've removed all of those. Let's power the amplifier back up. I'm just going to make sure that none of the drive circuit got damaged whilst we were messing around with that. So let's put this back down here, and let's put my camera back to this angle. There we go, look, it's kind of... Yeah. So yeah, I'm just going to make sure that the amp didn't get damaged whilst we were pissing around with that. Got the hiccups now. Okay, so we're only drawing 2.5 amps, 2.4 amps as you can see here. And the rail voltage has reached to 96 volts DC. So that's our positive rail. We shouldn't have anything on the high side, and we shouldn't have anything on the low side center. And yeah, you can see there that the bump happened. So we've got some of this reject low frequency. So if we have a look at the drive, okay, so you can see the drive wave is present there. See that? Yeah, see the drive wave there, which is present. And as soon as we remove the remote, if I put this camera to this view, as soon as we remove the remote, pop, it goes up to the negative rail and does something nasty to the FETs. Now, I don't think there's anything on the speaker terminals. When the relay clicks in, I don't think anything's on the speaker terminals. No, because there's no FETs in the board, so there wouldn't be anything on the speaker terminals anyway. So the drive seems fine. I haven't killed any of the low side stuff, any of the drive. It looks good. Yeah, it looks pretty nice. That's all fine. The high side, there's nothing there either. Yep, so the amplifier, all the drive circuit's fine. We haven't damaged any of that by messing around. So those 4 FETs that I just removed, let's take our transistor tester. Now I tested these before I put them in, but I believe one of them may have gone funny. Perhaps. Let's see. Timothy said he just rebuilt the card. Did that resolve your issue? Because I did think maybe that was my issue. Those 2 FETs were fine. That FET's fine. I reckon all these FETs are probably going to be fine. Oh man. Why? Why? Ah, they're all fine. That's not useful. That's not useful in the least. So how am I going to find... Okay, fuck this. Okay, so if Timothy Webb said that he resolved this issue by just rebuilding the driver card, perhaps that's what I should do. Perhaps I should just replace the 072C, the 211, and the LM26, whatever it was. Whatever the other one was, can't remember what it was. I've already replaced both driver ICs, the IRS-284S, so it's not those. So if I just go ahead and replace all the rest of the junk, then maybe that will resolve it. So, okay. No worries. What I might do is I might leave this amplifier for another night, another video. It's getting a little bit late here in the UK, so I want to make sure I'm fully focused on that one. And I'm going to grab out some smaller amplifiers that I've been working on, that I've received some parts for, and we're going to fit those back together. So I've got a Sundown SAZ1000 or something. I've got a... oh, what the fuck? Oh, my drawer came back. That's useful. I've got a Soundstream small amplifier to fix as well, and a couple other bits. So what have we got here? Ooh, look at this! Ah. Wait, hang on, this is interesting. Mark says, I looked into the 20N50. The diode TRR is 1300 nanoseconds. Mark, Mark, it sounds like you maybe know a little bit more about the FET specs than I do. So, can you fill us in what the relevance of TRR is? I imagine that's maybe a turn on or turn off time of the FET. But yeah, let us know what is that relevant to, and how does that help with the Class D switching section. I believe it's probably the lower the nanoseconds, the quicker the FET can respond and turn on and off. So I would guess that 1300 is a very slow speed. So what we have here is we have 100 IRF 640Ns. So I just ordered those earlier. So let's load those up into my drawer. I wonder if they're actually all going to fit. So I've got some remaining 640Ns in there, so we can put those to one side. So I'll drop all my new ones in this side. So they're all together. Do you think we'll fit the other 50 in there as well? Hammer knock, if you've got a tick when you remove the remote. Usually, sometimes amplifiers, when the remote is removed, there'll be a tick that comes from the inductors or from the transformers as they stop switching. That's quite normal. But also sometimes a tick can be the sound of current dumping through a component. So say, for example, when you remove the remote, all the FETs turn on and it dumps the capacitors dump all their current through the FETs. That can create a ticking sound, and it's the sound of the current going whoosh through all the components. They're not all going to fit. They're not all going to quite fit. I might have to squishy them around a little bit. Oh, there we go. I think that sorted it. So that's 100 640 ends in there. Nice, nice, nice. And now here we've got some IRFB 4227s and some capacitors that can go somewhere else. And we've also got some 31N20Ds. This is for the sound stream. So actually, I'm going to ask you guys the question. What would you guys rather I did? Would you rather I continued looking at this Ground Zero 10K and pulling the driver board out again and rebuilding the driver board, seeing if that makes a difference? Would you rather I did that, or would you rather I went on to Sundown 1000 watt SAZ and a Soundstream 1200 watt thing that needs new FETs? Tom wants the Sundown. Lil DZ Hank wants the 10K. 5K watt plus amps are more my flavour. Take a break. And comes fresh after a time. Do something else. Yeah, true. I've only just started on this amplifier tonight though. What basket is that sub basket in the back with the most spokes on top? This one is an old FI basket. Yeah, old FI basket. FI BTL, I think it was. Yeah. If you keep getting drop frames and long pauses, that's my fault. That's because I had Google Chrome open in the background with like a million tabs. So I just closed it, so the stream should be clean from now on, with not much many pauses. So sorry about that. Gonna have a cheeky vape off of my new bench power supply. Make sure that this is actually connected in there. Very nice. I was drawing, what was that? I was drawing about 16 amps, wasn't it? 16 amps, yeah. That was drawing. 16 amps at 9 volts, I think I was drawing for this mod. So most people want to do. So what we got? We got yeah, 10K Sundown. Okay, I think we got most votes for the Sundown. Sorry, most votes for the 10K. So I think I'll continue working on the 10K. I think we're gonna have to pull the driver board out. I could try and rotate the board sideways, like upwards, and hold it between my legs and work on the driver board at an angle. I might try doing that. I wonder if that's possible, because I don't want to keep having the driver board in this amplifier. The pins and the legs are very, very small and very tight. So I want to try and remove this driver board the least number of times if possible. I thought that it was repaired before, but clearly not. So, yeah. I'm surprised actually that this driver board, if it is the driver board that's at fault, I'm surprised that it got damaged so badly, because it's buffered by all these drive transistors, you see. So if the drive transistors got damaged, then I would have thought they would take the grunt of the damage and wouldn't damage the 21844S. If the 21844S got damaged, then I would have thought that by the time it got to that, it wouldn't have also taken out the 211. I've been following your videos for the past week. A few days I saw how you show to look for clipping with a speaker for low hertz. Do you have a similar hack for the 1 kHz? Yes, to detect clipping on 1 kHz, play it through your normal speakers and turn it up, and you can hear the clipping through the speakers. Because higher frequencies, when you play high frequencies like mid-range, mid-bass and stuff, you can hear the clipping through the actual speaker. The reason that we use this trick for the subwoofer amplifiers is because subwoofers are so inefficient at playing high frequencies, you can't hear the buzzing clipping sound coming through the subwoofer driver itself. So that's why we hook up a tweeter to the sub amp as well to hear the clipping. If you are wanting to detect clipping on your mid-range, mid-bass speakers, high-frequency vocal range speakers, you can actually hear the clipping distort the sound. So if you play a sine wave and turn the amplifier up, like play a high frequency, and it gets louder, when it gets to clipping, it'll go, you'll hear the buzz sound through the actual speaker that you're playing, whereas on the subwoofer it's much harder to hear that. You add a diode to get rid of spikes. Now, the faster the diode, the longer you live. Please look into current flow path in Class D and how important is the body diode. Okay. The thing that I'm concerned about is that this amplifier obviously shouldn't have the spike from, well, this amplifier would work. So the issue is on the board somewhere, an existing component. So I want to try and prevent adding additional diodes and other additional components to the board to try and rectify the issue, because that's just masking the problem. There's still an underlying issue on the board somewhere that's causing that to happen. So if I add a diode to mask the issue, it might work for a bit, but it might only last for a few weeks or a few months, and then the issue will get worse. So I want to try and tackle the root of the cause, the issue, at its source, rather than trying to mask it with diodes to get rid of the spike. TRR is the reverse recovery time of the FET diode only, but in switching application it plays a crucial role. Imagine spiking during opening circuit with inductive load, and what happens when you add diode. Ah, I see. Sorry, that was following on from your other comment. Sorry, Mark. I read your second comment before your first one. Okay, I see. Okay, so the faster the diode can act, then the better the FET deals with spikes, I think is what Mark is saying. The FETs is not the problem. My point was these N50s aren't the greatest for Class D. Cool, no worries. Actually, Mark, seeing as you're a man of good knowledge in this topic, the FETs which I opted to replace for this amplifier are, I have to remember the prefix, I think it's SHIG 460Bs. It's either SHIG or SIHG. Anyway, it's a G460B, which is a 500 volt part, and I think it's 20 amp as well. But I don't know if the TRR is any better or worse than the 20N50s. But I think those FETs which I bought are the ones this amplifier comes with from factory. So it'd be interesting to know how they actually look. What does your amp do when you remove the power first? Does it spike? That's a good question. Let's find out. So rather than removing the remote, let's see what happens if we remove the power completely but leaving the remote active. So if we just kill the power, what actually happens? Let's find out. That's a good question. I like that. That's logical thinking. So let's turn her on again and let's probe the low side drive, the one that's giving the spike. Over here, and let's turn it back on. Oops, it helps if I turn the power supply on. There we go. So, coming back to life now. Also helps if I plug my wires into the board. Over here, B+, ground, and remote. Woo! That comes on very fast. I've got to turn my current back down. Yeah, let's give it 6 amps. Okay, so rather than removing the remote this time, I'm going to go ahead and remove the power completely. So let's turn the power supply off and see, does it still bump? Yep, still bumps. You see that on the scope? So if I do that again, turn it back on, and I'm just going to zoom into the scope view. So let's turn it back on again. So low side drive, and then low side drive will turn off because it detects there's no FETs. So if we turn the power supply off and keep the remote turned on, yep, still bumps. Okay. So it's not a remote related issue. The real race fury, yeah, I'm good. I'm a little bit hay fevery actually. I suffer from hay fever. So yeah, I'm a little bit hay fevery today. I actually forgot to take a antihistamine today. I've been trying to take one every day, so I build up an immunity to it, but I forgot. Ghost Owl for me will follow up online. No worries, Mark. Thank you very much for your input on this live stream. Very much appreciated. I hope you sleep well. Okay, let's short out these. Let's short out these rectifiers to kill the caps, and then we can start work on the driver board. I'm going to replace everything on the driver board this time. Woo! It's a lovely blue colour, that spark. The bump is different now. The bump's exactly the same. The bump is down. No, the bump is up. The bump is up in negative voltage. Like, okay, so like whether it's down or up, to me the bump is higher negative voltage. So the bump goes like this, doosh. Like, to me, so I say that bump's up because it's bumping up in negative voltage. It's going higher negative voltage. Does that make sense? If it was bumping down, I'd say it's bumping down. Like, so if this is ground and this is our drive rail. So if it bumps down, I would go badoo like that, down. If it bumps up, I would say badoo like that. That's just because I see negative voltage still as a high voltage. So if it gets bigger and lower, like in the negatives, and I always say that's higher. It's higher negative voltage. I'm glad my sound effects make you laugh. That's cool. Right. So I want to work on this driver board, but I want to try and avoid taking the driver board out of the main board again because it's very delicate, the vias. So this is a very sturdy board. This is a very sturdy board. So I'm going to see whether I can hold it between my legs like this, and actually I need to move my seat back a little bit so that it drops down further. I'm going to see whether I can work on the driver board at that angle down like that. Let's push my seat back a bit further. Okay, yeah, that's going to work, but I just need to move my chair back a bit further, so I need to move some of this crap. Okay, so that should work now. Okay. Yeah, that looks good. Actually, yeah, I can actually rest this on the floor. Yeah, I can actually rest it on the floor and then support it between my legs like so. The only thing is you guys can't see what I'm doing. Maybe if I move my zoom in cam, you can probably see what I'm doing. Yeah, you can kind of see what I'm doing like that. Charlie is here. Ah, Carlos, haven't seen you for a little while. Good to see you on the live stream. Okay, so I think I can work on it like this. Yeah, that works. That'll be fine. Let's do that. So I want to remove the 072, the 211, and the LM. I think the 072 is on the bottom, the 211 is in the middle, and the LM is on the top. I think that's correct. Somebody actually told me in the previous live stream which order they were, but I can't remember what they said. But I think the 072 is on the bottom, the 211 is the middle, and the LM is on the top. There is a way to check it. I have to remember how to do this. It's been a little while since I've done this. Actually, where the flipping hell's my multimeter? Oh, I think I left my multimeter in the car. That's annoying. I'm almost certain that the middle one is the 211. I'm going to try and zoom in a bit on this so you maybe see. Okay, and if I think I need to bend this one a bit out of the way. Yeah. So the three chips we've got here, I think the bottom one is the 072, I think that one's the 211, and I think that's the LM. Can anybody else remember which way round they are? Because they're all scratched off. I can't remember. I'm just looking in my drawer of requirements for some chips to put into this. So I've got a little row of, what's that? Is that 072? Yeah, that's an 072. So now I just need to find the 211s. Thank you very much to R100 Evil 100 R1. Thank you very much to that guy, my friend. Yeah, he says he got the same driver card, 72s at the bottom, 211s in the middle. That's perfect. That's what I wanted to know. Thank you very much. I just need to find a spare 211, and then we'll be good to go. There we go. 211 is just here. So let's replace the 211 and the LM 211 and the 072. So I'm just going to take a little bit of solder flux. Drippity doo on the board. And take some tweezers. This might be difficult to get in here and film at the same time. Yeah, how the hell am I going to do that? Okay, I think that might work. Let's try. Let's try this. Yeah, Timothy, the cap and diode connected to the drivers, I see that all the time fails. But this driver board doesn't appear to have the same cap and diode setup. I know exactly what you mean. I've got one sitting here actually. Look, so this is the one that I'm usually on about. So the two, well, one of the caps here and this diode often die when the driver fails. But this driver board doesn't have that same setup. So. I need to replace the speaker input wire on a PRV 3000.1, says Scarrow. I was quoted $64. Yeah, I'm not too sure. I don't usually stock any of those parts, so I'm not sure how much they usually cost. This is anything but ideal. This is completely less than ideal. I don't like this at all. But I really want to try and avoid removing that drive board again. Oh wait, there we go. Yeah, she's off. Okay, that wasn't as hard as I thought it was going to be. Right, next one then. 211. God sake, the fumes from that flux are horrific. Oh, well, that came off very quickly as well, so that's good. Okay. Yeah, they almost came off too easily. Crazy. Right, okay, cool. So, let's take our spare 211 and drop that in. Nice DD hat, thank you. So the 211 is here. Can anybody remind me which pin on this 211 is pin number 1? Because it's not marked. Usually it's marked with a small dot, but it's not marked on this one. It has no notch in the side of the IC either. Hang on, I think I found one. So I think pin 1 is the bottom. So if I'm looking at it like this, I think pin 1 is right down there. So that would be upside. No, hang on a minute. So pin 1 would be that one. Yeah, so pin 1 is that one. Almost, almost. Ah, there she is. I think that's almost perfect. I'm just going to push down on the chip and heat it a bit more, so it just definitely is making a good connection. I can always go over it with my tiny soldering iron afterwards if I feel I need to. And now we just want the 072C. Ooh, live. Marin-law! Holy fuck! Marin-law, bruv. What are you doing here? Oh my gosh, that is a name that I have not seen for many years. Wow. Good to see you, buddy. How have you been? I'm watching you repair an amp. Yeah, you're watching me do some bullshit, some sketchy side angle shit with this driver board because I don't want to take it out the board again. Okay, let's get that in there like that. Try and get that roughly lined up. And that should roughly do. Mazda's waiting on my hot air station and should really start doing some repairs. Fuck yeah! I've watched you for ages. You're damn good at. Oh, thank you very much, dude. That's really, I really appreciate that, man. Thank you. I remember watching Marin-Law's videos back in the day, man. They were pretty sick as well. Marin-Law goes way back on YouTube. Way back in the day. There we are, there we are, I think we got it, I think I got it. Yep, I think we got it. I think that she's on. Nice. Okay, whew. I might go around and freshen up those solder pads and connections with my small tip in a minute, but I think they're actually all good. Right, so that's the 072C and the 211 replaced. So now it's just this one, which is the LM, and it's scratched off, and I can never remember the name. Someone mentioned it in the chat a bit earlier. I'm just going to scroll up in the chat and see whether it was what they said. LM2 something. Wait, it's probably on another board actually. Look, it's probably on here. If I check this other board. Is that one scratched off as well? Oh, damn it. Okay, let me try this one. All of those chips are removed from these boards. Why? Why are they all removed? That's annoying. Okay. I mean, I'm gonna take a wild guess that it's this chip up here. That's the chip that I need. But I can't remember because I can't read it. Let's get some. The trick is here: if you get some thermal paste on your thumb, on your finger, and you wipe it over the chip that you want to read, it makes it easier to read the letters on there. Sometimes, he says. Apparently. That one says 29. Oh, bugger. LM293. This is a 2903. Yeah, so this chip up here is a 2903. I wonder if that will work. No, it's not 211. It's the top one up here. The top one up here is an LM29 something. I think it's a 293. I've got a 2903, which is probably going to work the same, so I can probably steal that one if I wanted to. Mazda, you really need hot air. 95% of it can be done without. I actually disagree with Lil D Hanks a little bit then. I mean, yeah, you can probably do most stuff without hot air, but I found hot air to be an absolute godsend when doing stuff like this. Like, I would never be able to do this with an iron. Well, actually, maybe I would if I was pushed. If my hot air station died and I only had my iron, I would probably get it done. But it would be a flipping nightmare compared to how easy this is right now. Yeah, I think the hot air station is definitely, if you can pick it up, it's a good thing to have. I'm going to take a wild guess, and I'm going to say that I can nick the chip from this board. I think that's probably going to be fine. The 2903. 2903 sounds suspiciously like 293. So I think that's probably gonna be just fine. Yeah, screw it. Let's do that. Actually, isn't the 293 to do with protection circuit anyway? And protection circuit's fine, so I probably don't need to bother touching that. What I think I will do though is I will change the little 2D transistors up here, because I've got loads and loads of those 2D transistors and they're very cheap. So I'm going to go ahead and change those 2Ds. Yeah. Actually, no, the 2Ds, are they before or after the logic input? I can't remember. Actually, you know what? Let's leave them on there for now. Right, so I've changed the 072C, I've changed the 211. I'm going to turn everything off and I'm going to just see if that's made a difference. Alright, I'm just going to bring this up and inspect my work and see whether it's any good or not. Alright, let's have a look. How well are those legs soldered on? They look pretty good to me. Okay. There's no FETs in it. You are right. There are no FETs in it because it keeps killing them. So I'm finding where because the reason it keeps killing the FETs is because there's a pulse on the low side drive when the remote is removed. So I don't need the FETs in there to see that. So I'm going to see what changing those two chips has had any effect on this amplifier's operation. So let's plug it back in and see what it does. Alright, so here she goes. Okay, that's the same. Now, are we going to get a bump on the low side drive when we turn her off? Let's see. Yep, it's exactly the same. So changing those two chips hasn't done anything different whatsoever. Okay. Scarrow is off to do his alternator. See you later. Hey, Hunter, how's it going, buddy? Good to have you on the live stream. Ah, oh, this is headaches. So, I'm actually wondering whether this amp needs all of its output FETs in to work properly. I'm thinking whether I should actually just fit all these new output FETs in and see what it does. I don't know, what do you guys reckon? So you probe the gate. Yes, I probed the gate. So the gate, the low side gate drive, as we can see here. If I'm probing the gate, right, turn this back on. So you see it obviously climbs and builds the negative rail voltage. We get the drive, which then disappears because it detects there's no FETs in the board. Now when I turn the amplifier off, it bumps to the negative rail like so. I think that's what's causing the FETs to blow. I'm going to try putting some RCA voltage into this amplifier. Some RCA signal, sorry. I'm going to try putting some RCA signal into this amplifier to keep the low side drive active. And by keeping the low side drive active, I'm going to see what effect that has on whether it still bumps or not. Don't know whether it will. We can only try and find out. Use a computer power supply and 1 FET per bank. See if they blow up or you hear a tick. No, there is a tick. There's always a tick when you turn the amplifier off. That goes with pretty much every amplifier I've ever worked on. When you remove the when you remove the remote wire, there's a small tick heard from the board, and that is the sound of the power supply transformers stopping working. There's a small audible sound, and that goes with pretty much every amplifier I work on. That's not the issue. The tick isn't coming from the output section, it's coming from the power supply section. That's very normal. Yeah. So I'm going to feed this amplifier with about 40 Hertz, 47 Hertz, and let's see what happens. I'm not actually getting that signal through to the amplifier at all. What is that? Strange. Ah, there we go, there it is. Oh, there was anyway, for a moment. Yeah, it sort of does it for a bit and then it drops it off. Yeah, so it is finding my RCA signal is getting through to it. That's fine. I was just making sure my RCA signal was going to get through to it, which it is, because we can see there that it's 47 Hertz on that one there. That's fine. Why do you use AC coupling? I don't. I use DC coupling, as you can see. No FETs in, it won't start up. It is starting up. That's not the issue here. If you've been watching my previous live streams, you'll see that when I put FETs in, it kills them. Tell you what, let's all watch this video together and you can tell me what you think. Whoa! Those are building to the exact same level, and then the drive builds in, as you can see here, which is, and then it tapers off. I've got no FETs in, so it's not going to continue driving. So the difference in voltage between these two is about 10 volts. So if I now remove the remote, watch what happens to the gate probe, the line that's above. It suddenly, instantly bounces to the negative rail, and that will be turning the FET on fully. As soon as I remove the remote, the top line goes boom, straight and bounces. It bounces to the negative rail first, then comes back and then slowly goes towards it. It's very strange indeed. We can see there that there's about 10 volts there worth of difference, and as soon as I remove the remote, it goes to 0, and then there's no difference between the two. That one of them will bounce considerably low. Bosh. That is the issue. So yeah, that was that. That is the issue. And you saw the FETs explode like that, like crazy. Okay. Right. I'm gonna leave off so I'm gonna start off from where I started last night. So last night we finished the live stream and I loaded the amplifier up with 4 24N40Fs and they were 1D33AH batch and they were not dying. They were not being killed in the amplifier. So I'm pretty safe. I feel pretty safe going ahead to continue troubleshooting with these 24N40Fs in the board because I don't think they're going to explode. So I can try a few different things with these FETs. If I can fucking find any of them now, they've all gone missing. Right, there's another one. There's another one. And there's another. Right, so I've got 4 33AH FETs here. There are some low-end resistors on that card that will open up. I just found a picture of the driver card looking at it now. Okay. Timothy, can you point me in the location of the resistors which you believe will open? Give me the resistor number and I'll check those. Maybe I skirt it in the power supply section is causing them to take too much power into the MOSFET. No, the issue is coming from the driver board. Well, it appears to be coming from the driver board. So I probed the logic input of the IRS21844S. So the pin 1 of the IRS21844S is the logic input for the drive waves, and that exhibits the same bump, the same pulse on it that it sends to the gate that seems to be causing these things to explode. So it's coming somewhere on the driver board in the Class D generation circuit, but I can't figure out where. Yeah, this my live stream group chat seems to always have some really good knowledgeable people on. So if I'm ever struggling with an issue, I always like to jump on the live stream because lots of knowledgeable people in here that are always willing to help a hand, to lend a helping hand. So yeah, pretty cool. Alright, so I shorted out my regulators, that's fine, and I'm just going to go ahead and solder these 33AHs to the board again. Now these were fitted to the board last night and they didn't explode, so I'm hoping that this is going to be fine and not explode again. Okay. Okay, so these FETs are soldered on. These are 24N40Fs, and these were not, I repeat, these were not exploding yesterday. Yesterday I did lots of tests with these. I turned the amplifier on, off, and these did not explode. So I am hoping that we are going to see a repeat of last night and that these don't explode, and I can continue to further troubleshoot the issues with the amplifier with these in the board like so. Alright, let's turn her on, and moment of truth time. Will it explode? Will it not explode? Okay, not exploding. That's a good sign. Okay, so not heating up, not exploding. So the amplifier is obviously happy with 24N40Fs being in the board. Right, let's measure what goes on the speaker terminals, on the speaker outputs. So if I take another probe, let's steal the high rail voltage probe here. And let's attach this to the speaker output. Which is going to be one of the outside ones here. Okay, I'm just going to have to hold it on here like that. Okay, let's go again and see whether there's any DC on the speaker output terminal. There shouldn't be any DC on here at all. No, it bumps up to like 1 volt, so I think we're okay there. That's pretty normal. There does seem to be a bit of a bump on the negative speaker terminal though. If I turn my attention to the scope screen here. So if I probe the negative speaker terminal only, it's like negative 1 volts on the negative. On the positive and on the negative, yeah, it doesn't really bump up anymore actually. That's very interesting. It was bumping up before quite a lot. Now before my previous live stream, yesterday night, I haven't really changed much. This resistor here was getting stanky hot. There was a small, if you remember from live stream last night, there was yeah, still getting stanky hot, okay. Not as stanky hot, it's getting like 40 degrees. Yeah, so it's still dumping some pretty hefty spike. Right, I'm gonna now, next thing I'm gonna do is I'm gonna probe the low side output. So I'm going to probe the low side drain. Right, so the drain of the low side FET, I'm going to probe that, and we're going to see whether there's a voltage spike on that when we turn the amplifier off, because I think there was last night. So if I go back to scope view, so oops, we shall see the low side drive and the high side drive come into play, and I think there'll be a voltage spike on the high side drive. Let's see. I need to turn this back up to 50. There we go. So there's a high side drive. Ah, interesting. There doesn't seem to be a spike anymore. There was a really big spike last night, and it doesn't seem to be there anymore. I wonder whether changing the TL072 and the 211 actually did fix something, even though it didn't look like it did. Right, now I'm going to apply a static load to the speaker terminals, right? So this is what I was doing earlier with the other FETs in the board. So if I put a static load on the speaker terminals, we'll see how does the amplifier like having a load on the speaker terminals. Because it didn't like it earlier, which is really interesting. So I'm going to see how it likes it now. I'm just going to put a 4 ohm load. Stick a 4 ohm load on the speaker terminals. And let's see what she does with the 4 ohm load on the speaker terminals. I'm going to make my scope view a little bit bigger here so we can see. Okay. Something weird happens, doesn't it? Did you see that? Something weird happens as soon as the relay clicks in. Something weird happens with the rails. I don't like that. Something weird happens with the rails as soon as the relay clicks in. Let's see that again. I'm now probing the high rail and the low side drive. Whoa! Okay. Yeah, so something's fucking not happy at all. It's just blowing the FETs again. Ah, man. Okay. Yeah, so I'm definitely not loading the new FETs into this board. It blows the same too. It blows the high side from this side and the low side from that side. It's the same 2 FETs, always. Hot dang it. Okay. Ah, jeez. So again, they exploded as soon as I removed the remote. Weird. Hammer Knock, what amplifier is it that you're working on that's doing that? I'd love to get to the bottom of this one. I hate having these issues that don't seem to make any sense. American Legacy 5K. Okay, that's a different board design to this one. We will get to the bottom of this one, just like we got to the bottom of the Lands R7K. you remember the Lands R7K that had the fault with the drive was the wrong shape? Do you remember that? Found the cause of that in the end, and so I'm sure we'll get to the bottom of this at some point, but maybe not tonight. I feel like I want to have some repair success this evening, so I'm going to put this to one side. I'm going to fire up the Sundown 1K, and I'm going to do a bit of work on that. Put this to one side, so I feel like I've been relatively successful this evening. Oh, look at the difference in size. Okay. So far as I'm aware, this just needs new FETs. Okay, so this is a Sundown SAE 1000D, not an SAZ, sorry, it's an SAE 1000D. And this came in with some vibration damage, some dead output FETs. So we've removed all the dead output FETs, so naturally the first thing that we always do is I'm going to power the board up just like we were with that big ground zero. I'm going to do the same thing with this, power it up without any FETs in the board first. Measure the drive waves on the output section, make sure that they look healthy and not a weird shape. And then provided we're happy with the drive waves, we can fit the new FETs and it should just work fine. There's always someone that dislikes your videos on YouTube. Like, you know, it's rare that you ever have a video on YouTube or a live stream or something that, you know, has a reasonable amount of viewers. It's unheard of that you never get any dislikes. Like, all the videos have some dislikes on it. It's just I don't know who puts dislikes. I don't know, some kind of haters or something. I don't know. It's really weird. I've no idea who'd put dislikes, but they're always there. So yeah, just it's cool. I don't mind. They don't like that he gave up with the 10K. Yeah, probably true. Okay. Yeah, so let's power this up and see what this one's doing then. So this is yes, like I say, Sundown SAE 1000D. It appears to just have a dead output section. Now I'm going to zoom in on this board so we can see how this circuit is working. Oh, I've got the hiccups now again. Alright, let's have a look. Where is the output section? This side. Okay, yeah, over here. Oh man, this freaking zoom in camera drives me nuts. It doesn't even stay up here properly. Need to get a better setup for this. Right, okay, there we go, that'll do. Yeah, so this is the output section. We've got two banks of FETs, really simple. They are 4227s. This is the driver IC. Now this is most likely an IR2010S. It could be a 2113. I see the BAMF, the Power Acoustics BAMF was using a 2113, but the 2010S is a slightly better chip. So they've scratched it off, but I bet you any money it's the 2010S. So yeah, I imagine that's probably fine. They're quite hardy. They don't tend to die too often in these small amplifiers. So I should be able to power it up, and we should be able to see the low side drive waves are looking relatively healthy. So let's see. Yeah, so it draws 0.2 amps, which is good. I need to change my camera angle so we can see that. Yeah, so when I power it up, it draws 0.2 amps on idle. I've only got 8.5 volts going. Let's crank that up say a little bit. 9 volts. There we go. So I'm looking at probing the low side drive, which is going to possibly be this one. Note that appears to be the high side, so the low side drive is probably going to be over here. There we go. Look at that. Yeah, looks good to me. Looks like a nice healthy drive wave. There again. Yep, that looks the same on all those. The high side won't give any drive waves because the high side never oscillates unless the FETs are in. So we've got a rail voltage of 39 volts with 9 volts worth of input. That looks good to me. Yeah, so we can pretty safely just go ahead and drop new FETs in, and this thing should just work straight off the bat. I just need to wait for the rail voltage to sink back down. Hunter, my phone's dying. No worries, buddy. Thank you very much for joining anyway. So just waiting for the rail voltage to sink back down. And while we do that, let's get our FETs ready. So we've got these ones here. 4227 PBF. So we need 6 of those. 1, 2, 3, 4, 5, 6. There we go. Put this. Where can I put these? Where can I put these remaining ones? Or maybe I'll keep in the bag. Cool, we've got 5 volts left on the rails, so I can safely go ahead and short those out on the rectifiers using my tweezers without any crazy sparks. There we go. Yep, easy. So let's suck the holes and fit the FETs. Yeah. live chat seems pretty active tonight. Nice. Yes, you're right. I need to change the current amp description on my live stream. Yeah, I always forget that because I only just implemented that. Let's change that to. There we go. So now I have the current amplifier. GZ10K smoked again. Yeah, man, for sure. The GZ10K lit up again. For sure. Yeah. It's okay though, it didn't kill any expensive FETs, so that's fine. It just killed some old FETs I had laying around. Uh-oh. The RDS of these FETs seems to be all over the place. I wonder if these are legit or not. Ah, shit. The RDS is all over the place. I hate using these. Well, I say it's all over the place. We've got a minimum of 0.5 ohms, a maximum of 1.3. Okay, that's probably fine. I just don't like it. Makes me wonder if they're fakes when the RDS is jumping around like that. Now this amp actually had a solder attempt by the owner, or the owner's friend or something, and the solder attempt was pretty bad. So we do actually have some broken traces on the top of the board where the soldering attempt was done badly. So I'm going to try and zoom in on those so we can see what that looks like and how to fix it. So if we take a look here, we can see that this diode and gate resistor does not connect to the MOSFET gate. See that? The diode is just floating around there and there's no connection to the gate whatsoever. It's also been lifted from the trace of the original diode, which is no good. So we're going to have to run a jumper wire from this trace, this pad here, to the gate. Just checking all the others okay. Yeah, the other stuff looks alright. So I'm going to take my small pointy tip tweezers, soldering iron tip, not tweezers, just pointy tip. And I'm firstly going to go ahead and resolder both sides of the diode to the board. This amplifier, this amplifier is definitely Chinese made. Actually, all of, well, no, yeah, this amplifier, I think, anyway, I believe this is a Chinese made amplifier. Now the FETs didn't come with this amplifier. They're shady. These are ones I ordered, so it could be the supplier. The FETs that this amp came with are probably fine. Right, let's see if that. I think my cap was my cap in the way then? Yeah, my cap was in the way. Sorry about that. Yeah, so the diode is now back on the board nicely. So I just need to run a small jumper wire now in order to get that connected back up to the gate. So let's see, what bits of wire have I got laying around on my bench I can use for this? Okay, I need a bit more of a bend on that. There we go, that should do the trick. Whoops. There we go. Yep, I think she's looking good. Nice. So guess there ain't no use, 'cause I've seen better days. Be the start of many days. I've seen better days. And the bomb drops out. So I can't. I left my multimeter in the car, so I can't actually do any multimeter checks with this. So I'm just gonna have to wing it and hope that it works, because I'm too lazy to go and get my multimeter from the car. So I'm just gonna do a scrape in between here to make sure there's no solder bridges. I'm gonna trim the legs off these as well, just while I'm here. Cool, okay, and yeah, so that should work. Let's see. I'm going to give it a tiny bit of power first, just to get the rail voltages kind of present by like a tiny bit, and that will let me see whether there's any leaking voltages anywhere. So let's see. Whoa, wow, that comes on really fast, doesn't it? Jesus Christ. So yeah, 35, so we should have just positive on there and nothing there. So I'm going to go back to my zoom cam so you can see what I'm doing. So on the high side, we should have just positive rail on the middle and nothing on either side, which is correct. So these are all high side in parallel. That's great. And the low side, we should just have negative rail. Oops, go over this side. We should just have negative rail on pins 1 and 3 and nothing on pin 2, which we don't. So there's no voltage leaking anywhere. So let's go ahead and turn her on fully. And make sure that it works. So if I probe the high side, we should see the drive wave appear on the scope, just like so. I'm going to turn that to there. Okay, I didn't see any drive waves just then. That was interesting. Oh wait, there we go. Drive waves. Yeah, there we go. It's only drawing 0.5 amps, so that's not much power at all. And let's just feel the FETs for heat. Nope, they're all stone cold, so I reckon that's probably fine. So I'm just going to leave it powered up for a little bit longer. I'm just going to make sure that that repair that I did was good. Yeah, you see that repair that I did? That's looking good there with the drive wave. Low side drive looks fucking beautiful. That's a gorgeous low side drive. Look at that low side drive. Look at that. That's a love. Well, it's not bad. It's a pretty good shape. It's maybe a little bit too high gate resistor value, but it's fine. Alright, so that was on for about 30 seconds or so. Yep, stone cold and stone cold. So yeah, this repair is good to go, probably, provided it bench tests okay. Now, interestingly enough, I'm just curious to see, does this amplifier do the same thing as the ground zero? So when we turn it on, is there a spike? No, there's not. There's no spike, is there? Although maybe there is, because... now this is interesting. Look, if I go to scope only, right. So check this out. So with the ground zero, when there's no drive wave, it's sitting at this... It's sitting at the top, sitting at here. So when I turn the amplifier off, it bumps down to where the top of the thing would be, which is what this amplifier is doing as well. So maybe that's normal. If we probe the output of this, when we remove the remote, it does, look, you see it bumps to negative rail. That appears to be normal. I've seen that on most amplifiers. When you turn it off, it always starts at negative rail and comes back to ground, comes back to zero. Doosh, like so. So that appears to be normal. Normal operation. These are stone cold. They're not stanky hot. I like that people pick up on my shit that I say. Stanky ass hot and stone cold as fuck. Will you be uploading the edited version of the Vibe Reaper, DC9K and Lanzar 7K? Yes, my friend. The Vibe Reaper isn't finished yet because the FETs are taking 2 months to arrive because I accidentally ordered ones on a back order. So the Vibe Reaper isn't finished yet. The FET is pretty much ready, but it's just waiting for new FETs. The DC9K, yes, I will upload a video of that once I get around to editing it. And the Lanzar 7K, again, yes, that's a very long edit because there was a lot of live streams where we were troubleshooting the issues on that. So I will upload that as well at some point. Cool. Oh yeah, this seems to be successful repair. If I probe the speaker output, just very curious, I'm interested as to see because this is helping me out with the ground zero a little bit. Yeah, it appears to be that on every single amplifier, every single Class D amplifier, when the remote is removed, the speaker positive bumps to negative rail. That appears to be normal operation. So, okay, that's something to bear in mind. I started my channel up. Turns out I'm camera shy, but I just went for it. I even went live a few times. Yeah, it takes a while to get used to. I think I was a bit camera shy at the very start. But yeah, you get used to it. I don't give a fuck now. I'm so used to having people watching what I'm doing. I'm so fucking really used to it now. Ain't no thing, girl. Okay, so this is a successful repair. That's good. I can put that away. That was literally really easy. That was just FETs. To be fair, anybody could have done that. Anybody could have. Well, apart from maybe this stanky bit of soldering. That was, you had to know what you were doing there. But apart from that, it was just FETs, so that was pretty easy. Cool. Right, let's remove the power from this, and I'm gonna get out the Soundstream amplifier that appears to be dead. Now, the Soundstream amplifier had a few issues that was wrong with it, so I'll explain that in a moment. Let me just go and get it. Alright, so this is the Soundstream that I'm repairing. Now, this is one of the Class Ds that I absolutely flipping hate. This is the really old school Class D design that uses this style of drive circuit. This is the driver board when it focuses, if it will ever focus. Maybe I need to zoom out a bit. So this is the same type of amplifier as the flipping Evo 5000. Remember the Evo 5000 I had crazy fucking headaches with? Yeah. This is one of those. Now, this amplifier came in. Apparently someone had tried to look at it before but failed to repair it. Now, when I got this amplifier, I turned the board over and I noticed on the back... Where are we? One of the... Here we go. There. Right. You see this inductor here? This inductor smooths the outputs of the rectifiers. So the power supply is here. Power supply drives the transformers. Transformers then go into the rectifiers, and then there is an inductor here which smooths out the output of the rectifiers. Okay, it gets rid of high frequency noise on the rectifiers. Now, when this came in, I turned this over, and this actually had a blown. It's had a blown hole in the board here. So you see there's still a little bit of a hole here, and so this inductor wasn't making a connection against this trace, and as a result the output section didn't have its positive rail. So the positive rail wasn't present, so the amplifier wasn't coming on, and there was no switching going on. Now I repaired the trace and I powered it up, and some of the output FETs were getting hot. But they were all switching and working, but some of them were getting hot. None of them I don't think have been replaced. None of them were shorted, but some of them were getting hot and some of them weren't. And it seems to be like ones in the same parallel bank that were getting hot, which is very unusual. Usually if there's a drive fault, then all of the FETs in the same parallel bank will get hot together. But this was just like the odd one getting hot. So I thought maybe the FETs have gone out of tolerance and they are no longer, you know, working together happily. So I ordered a whole bunch of new FETs for this amplifier, and you have to be these amplifiers are very picky with what FETs they have, so you have to order the originals. So I ordered a whole bunch of new FETs for this. So I'm going to completely swap out the FETs, put brand new FETs in, and see if that solves the issue of them heating up. In my class, I can hand like Laurie. Miss the bus, but I'm in no hurry. Business class, no business border. 1 foot in the hole, 1 foot getting deeper. Back to me, blowing sweet air. I ain't got much to lose. So I'll see better day. First I'm in your praise. Why is everybody saying happy 420? What's that all about? Is it the anniversary of when marijuana was legalized in some states or something? What was the fireworks I missed? You missed the ground 10K smoking up the FETs again. Please be a DTR amp. What does that mean? Pot Smoker's Holiday. What does that mean? What's the Pot Smoker's Holiday? Why is it a holiday for pot smokers? What's that all about? You know, it's still illegal over here in the UK. Everyone does it, but it's still illegal. Yeah, I understand that 420 is the weed reference thing, but I don't understand the reference of today being 420. Oh, today is 420! Right, of course, yeah. So the reason that I didn't get that is because in the UK, we say the date the other way around. So rather than it being 4-20-18, in the UK, we read it as 20-4-18. So when it's like 24, like, what the fuck? Yeah, it's April 20th. So 420 day doesn't exist in the UK because there's no 20th month. There we go. Now I can load her up with the new ones. 31N20D. So without looking at the data sheet, can anybody guess what voltage and current rating 31N20Ds are? And you can work it out by the name of the FET. You don't even have to bother looking at the data sheet. The name of the FET should tell you its voltage and current ratings. – 31 amps and 200 volts is correct. Yeah, buddy. That is correct. They name the FETs very nicely. Very easy to know what voltage and current handling they are. And does anybody know why there's an N? 31N20. What's that? What's the N mean? N channel is correct, yeah. So the name, not all names of FETs will be like that. IRF 640 doesn't really tell you much about what the FET is, but all the ones that are like a number and then a letter and then a number, like 69N20 or 12P20, the first two numbers will be the current handling. And then the letter will be the channel of the part, so if it's an N channel or a P channel MOSFET. And then the last two numbers will be the voltage rating divided by 10. So for example, a 50N06 would be 50 amps, N channel, and 60 volts, because the 06 is 60. If it was 50N60, it would be 50 amps, 600 volts N channel. And that would be a pretty damn stanky ass FET. 600 volts and 50 amps, yeah, that would be fucking epic. That driver board is triggering me. Yeah, for sure, man. I feel you on that one. Me too, bruv. absolutely hate these driver boards with a passion. This style of Class D amplifier I hate with a passion. It's fucking awful. It's rubbish. Piece of crap. Excuse me. How much USD would you charge for a fit repair like that on the Sundown? USD probably like 40 bucks maybe, something like that. It's more my time really. Like there's like a minimum charge. So generally my minimum repair fee is like £35, which is about 40 bucks ish. Even if it's something pretty simple like that. Like there's you know, there's got to be a minimum charge to make it worth my while. Do you have any pets? I don't know. I'm actually pretty allergic to furry animals, which sucks. So I can't have any cats or dogs or hamsters or anything like that because they ruin me. Ah, crap. I have fish and snakes. I used to have fish. I've never had snakes. I feel like you've got to be pretty dedicated to have snakes. I don't really have a lot of spare time, so I wouldn't want to neglect them. So, also, it's not really my jam. It's not really my hobby. Like I appreciate them, but I probably would never keep them. IXYS 32p 60p 32 amp P channel 600 volt. What was the craziest one I saw? I saw a pretty, actually let's go crazy fet hunting. That sounds like fun. Let's go crazy fet hunting, shall we? Let's go to RS Components to see what, let's see what the craziest fet that they have on RS Components is. So let's go for, okay, so we're looking for crazy current handling. Let's start with crazy current handling. Maximum continuous drain current. Let's see what we got. It takes a while to load this massive list. Give it a sec. There we go. Okay, whoa! 645 amp? What the hell? So let's tick these top three and see what these are. Whoa! Hang on a minute, what? Wow, that's huge. So, look at this, guys. If you, well, no, you couldn't write. So, if you could dissipate enough heat from these, you could run just 2 of these MOSFETs, and you could probably run like a 10K amplifier power supply using just 2 of these FETs. Maybe I don't know how it works. You probably couldn't, but I mean, just looking at that current handling, that's fucking ridiculous. 40 volts. So you could run a car audio amplifier power supply on that, and if you ran 2 of them to drive a transformer, you would only need 2, and a lot of power would come from that. And they're only no, that doesn't make sense. They're like £4 each. How is that possible? That must be a typo, surely. That's got to be a typo. Look, this is a tiny surface mount device. How can that be so much current? That's got to be a. Let's look at the data sheet. Shit! No, it is right. Here we go. Wait, what? Continuous drain current. Silicon limited. 10 volts. 25 degrees. I'm not understanding what the differences are here. Oh, TA, temperature of A, which is temperature of what's A? What's A? Temperature C, I guess, is temperature of case. So if the case temperature is 25 degrees, then apparently it can dissipate 645 amps. The fuck? Wow, the pulse avalanche energy is massive as well. Maximum power dissipation. Only 341 watts though. 3.8 watts. Yeah, that doesn't make a lot of sense. Alright, let's screw that and let's look at MOSFETs that are going to actually fit in our amplifiers. So let's remove all these. And let's have a look at package type, and we're going to go for like something large. So we're going to go, actually, let's go for pin count 3. So we want 3 pins. 3 plus 2, no. 3 plus tab, no. 3 plus tab. Right, let's do all these 3-pin ones, okay? And let's now go for maximum continuous drain current. Wait, Billy Armstrong. IXTN 66N04. 660 amps, 40 volts. Wow! Fuck! That's crazy. I wonder how much they are. Anyway, so let's scroll down and have a look. So we've got, again, some pretty hefty FETs up here. Let's tick those. Let's see what those are. Wow, this is a TO220 part? No way. Right, here we go. This is a what do you call it? 247 package. So these are £5 each, and they are 380 amp, 24 volt. Not bad. Let's look at the biggest continuous drain current ones. Got 380, 36. So the biggest, yeah, this is the biggest, 380 amp, 24 volt. Now the ones that were suggested in the live chat IXTN66N04T. Let's check these out. I don't know if these will be on RS. I wonder if there's a dash. Nope. Let's see whether they're on Mercatio. No results found for those. So I don't know where you can buy those, but they sound pretty crazy. Billy, if you know where you can buy those, let me know, because I'd be interested to see how much they are, just out of pure curiosity. Anyway, enough of that. Let's continue with this repair. Bevis, what scores are you getting these days? Not much really. I've not really had a loud system for ages. I'm doing more SQ now. Right, okay. So we fitted new FETs in this. So let's just apply a bit more solder to a couple of these. Alright, and let's hook her up. And this will be the last one before I shoot off to bed, I think. And hopefully this will work and not heat up like it was before. That would be nice. So yeah, if anyone hasn't seen my latest video of my T-line door cards coming along, then go and check that out. I'm really happy with how they're sounding, and I'm going to try and get some better video footage, some audio recording footage of them with the stereo image, so you can really hear what it sounds like. It sounds amazing, but obviously the camera doesn't do it any justice at all, so I'm going to try and get a decent audio recording of that. Alright. Hopefully these don't heat up like the others were, and it's going to be good. So let's find out. Turn the good old trusty power supply on, and let's get this thing up and running. .5 amps we're drawing. Ah, what? Oh no, I remember now. This amplifier needs to be kick-started with some RCA signals. So let's go ahead and give it some RCA signals to get it kick-started. I think it's this one. There we go. Okay, let's see. Is it heating up like it was before? Okay, nothing seems to be getting hot this time. It does draw some pretty high current actually when it kicks in. So let's allow 4 amps to pass. I just realised that this camera was fucking all over the place. So as you can see, it does draw some pretty high current when it kicks in. So I'm just going to let it do that again. There we go. So 2.2 amps it draws, which is quite high for this size of amplifier. And turn it off, and let's see, is anything getting hot? Yeah, they are getting a bit warm. To be like, this one here gets a bit warm. Interesting. I wonder if the drive is any different on this one to the rest of them. So the drive is like, it's got a bit of a curve on it. It's changing shape quite a lot. It's shifting around quite a bit, which is interesting. Okay, let's compare that to the one next to it, or the one on the other end that's not getting warm. It's kind of shifting around the same. The shape looks the same as well. 2.3 amps is drawing again. Okay. So lukewarm, cold, cold, like lukewarm, lukewarm. So they are all getting a little bit warm actually, you know. These ones are stone cold as fuck. So this bank is stone cold as fuck. But this bank is getting like a little warm to the touch here. So I wonder whether the inductor is maybe damaged a little bit, perhaps? It's possible. Yeah, the inductor actually looks like it might be a little bit damaged. I'm going to measure the inductance of that one to see if that's any different to the other one. See if the inductors are different values. Okay. Yeah, they're sort of getting warm to like roughly the same temperature and then tapering off. Yeah, I don't know. I'm not convinced that that's great. So we're going to measure the inductance of both inductors and see whether there's any difference there between the two of them. You should check out Tectonic Elements drivers on RS Components. I'll check it out. Where did the slope go on the drive wave? The slope was there and not there because I was probing different points on the drive. So the slope is there on the high side gate, but the slope is not there on the drain of the low side FET. And the slope is there because the gate of the high side has capacitance on the gate leg, which causes the slope because it's yeah. Alright, let's go ahead and measure those inductors. So we're going to take our transistor tester. I'm going to try and find some spare wire laying around somewhere. There we go, that'll do. Spare wire. I vaped off the input terminals of the amplifier, as you do. I could turn my power supply up to 20 volts and 20 amps and have a crazy powerful vape. And that would actually be more powerful than the Dell server power supply vapes, because Dell server power supplies are locked at 12 volts, so it'll only draw as much current as the coil has resistance. Man, this is sketchy. This is a sketchy ass setup. Right, okay. So if I go ahead now and stay in the fucking holes. Stay in the holes, damn it. Okay. Output section is over here. I don't know where. What the right, yeah. These are the output inductors here and here. Right, okay. So let's first of all measure this output inductor. See what that does. So that's saying. Okay, so this one is measuring on the transistor tester, but you can't see it at the moment because it's on the bench. This one is measuring a steady 0.3 millihenries. And the Q is very low at 0.8 and fluctuating between 0.0 and 0.8. So a very good Q. It's 0.2 ohms, and the L inductance is 0.3 millihenries. So let's go over to the next one and just check the next one. The next one is also 0.3 millihenries, but it's not giving me a Q reading. Oh no, now it is. Q is 0.1. Okay, so both of these inductors are identical. That's curious. So the inductors are not the issue there then. They might not even be an issue, it might just be a really shit design. They might just get hot because they get hot, you know? It's weird that they get hot though. Alright, let me bump my power supply up, because let me bump it up from 9 volts to... Let's bump it up all the way to 14 volts, because that's what the card's going to give it. The card's going to give it 14 volts. So if I bump it up to 14 point something, okay, this is what the card's going to give it. Flipping grounds come out. Ah. Okay, so the card's going to give it 14 volts. So if I power her up with 14 volts, let's see how hot they get on 14 volts. And let's get my RCA ready to start it into operation. I think whoops, I chose the wrong probe. I have two identical probes and I chose the wrong one. My bad. Let's try that again. That's better. There we go, 2.7 amps, and let's turn it off after a couple of seconds of operation. And how hot did I get? Not that hot, like lukewarm like before, but there's a huge difference between the heat of these four and the heat of these four. These four are dead cold as fuck. These ones are like getting a little stanky warm. So I wonder whether these four are kind of out of tolerance a little bit. So I might replace these four and then find some perfectly matched ones in the transistor tester to load up. Let's do that one more time. There we go. Operation. Turn her off. How hot do we get? Yeah, we're getting quite hot, like to the point where it's actually almost too hot to touch. So, yeah, no, I'm not happy with that at all. That doesn't make me happy. So, fucking cold as hell, pretty damn hot. So, yeah, it's the high side fets to getting hot. So, tomorrow I'm going to try and remove those and try and match them up with an equal batch. And we'll go from there. Yeah. So, yeah. Okay. If hot is stanky hot and cold is stone cold, what is in between that? Lukewarm. Well, like, it's kind of warm. Guess that ain't no use. I've seen you do. Should we crank up the voltage on this and see how powerful this vape gets? So what are we on now? So that's 10 volts. It's a bit too bright in here. If I turn that light off, that's a bit better. It looks a bit overexposed on the camera. It still looks a bit overexposed actually. Ooh, this is getting a bit dry. Wall socket the vape, yeah. I'm not sure how the vape would react to AC actually, because it runs off DC. I mean, it would still power up on AC, wouldn't it? So I could technically run it off of an amplifier. Very nice. So that was 10 volts. Let's crank it up a little bit. I think it caps off at 10 volts. I think the current caps off at 10 volts. Look, check this out. Yeah, so it caps it off at 10 volts. I can't do any more than 10 volts because the current draw is like 23 amps. Turn it down a little bit. Turn it right down. Like 2 volts. 2 volt vape. It's like a little chimney. Let's go up a little bit. 4 volts. 4 volts is like a nice slow vape. Five volts is a nice slow vape. So I think 7 volts is like the sweet spot for this. Should get V Dennis. What's happened with V Dennis these days? Where is he anyway these days? I haven't heard from V Dennis in like the longest time. I actually deleted him off MSN because he was a bit weird. V Dennis was getting a bit weird. Yeah, V Dennis was getting a bit weird. He wouldn't stop going on about my Rotels and their dimples. He's in China. What's he doing in China? Kinky Tigger says another tech that deals with amps. Yeah, buddy. I'm probably the only guy in the I think I'm the only guy in the UK that's like actively repairing big car amps, like 3K plus. The amp doctor has far superior knowledge than I do. He's been doing the amp repair stuff for like 25 years or something. And yeah, but he doesn't do anything over 3K now because it's too much headaches for him, and his business is more oriented to research and design for brands like DLS, Vibe and stuff like that. He tweaks all their amplifier circuit designs, makes them run more reliable, do more power and run cooler, things like that. He's working there. Ah, cool. I miss photonic induction. Yeah, me too. You know, photonic induction actually lives about 10 minutes down the road from me. Not even 10, yeah, 10 minutes? Yeah, about 10 minutes down the road, photonic induction. If photonic induction was still active, I would actually message him and I would be interested in doing a collaboration. I don't know what we do. What would we do? What would me and photonic induction do? I mean, he's got a lot of power. He's got fucking lots of power on tap, so maybe we could do some crazy bench tests, some crazy amp dynos, like see whether a Times 15K actually does rated power, for example. I watch stuff like you all the time. I rigged my own little setup based on lots of you guys' videos. Cool, that's wicked, man. Nice one. You see the videos on the new K9s? No, I didn't. I haven't actually, no. Yeah, I'd love to do some stuff with Photonic, but I don't know what he's doing these days. He's proper inactive for fucking ages. I heard a rumor that him and his wife split up. So him and his wife used to do the YouTube channel together, but I don't know if him and his wife maybe split up or something, but I did hear a rumor about that. Oh shit! V Dennis is here. What's going on, buddy? Did Marin-law get you on the live stream? Old school times. I feel like I'm back on MSN again. I tell you, I feel like I'm back on MSN. We've got Marin-law, we've got V Dennis, we've got Rowan, all the old boys. Oh man, this is fucking. Who else did I used to chat to on MSN? Calvin. I used to chat to Calvin on MSN a little bit. Xlay. Where did you get your dummy loads? I got them from eBay. They came from China. So I think it was like £95 for 4 times 4 ohm 1000 watt dummy loads. I opted to go for 4 sets of 4 ohm 1000 watt because that gives me more wiring options when I'm doing bench tests. I could have bought a single 5000 watt 1 ohm, but then I couldn't change the impedance of that. So no, MSN isn't there anymore. MSN shut down their servers years ago, much to people's dismay. Where'd you get your solder from? I get it from eBay. I get 40-60 solder. Sorry, I get 60-40, I think it is. 60-40 solder from a specific brand that I have used that works really well for me. I'm not on Kick. I've had Kick at times in the past, but there's so many messaging apps these days: WhatsApp, Facebook Messenger. I don't feel like I need Kick really. Huh. Oh, back down to 6 volts. Dan, how's it going, buddy? I can't believe there's still people joining the live stream now. I'm about to go to bed. How many people are watching? Only 37 watching. Okay, that's pretty low. Calvin called me a nice mental type because I was born with a condition. No, that's a shame. I didn't really chat to Calvin much. Just bits here and there, really. I asked you earlier about a good replacement. Oh yes, sorry Josh, I spotted your thing and I meant to reply to it. IRFP 40N10. So you're looking for a 100 volt part roughly and 40 amp. Okay, let's see. So can you not find the 40N10s anywhere then, buddy? So it's usually best to stick with the originals if you can, especially on output FETs because they can be a bit fussy. Let's bring my camera over a bit. Let's see. So you are looking for a part which is roughly 100 volts and at least 40 amps, and that's relatively quick with a low RDS. And low input capacitance and low gate charge. So MOSFET transistors. Let's see what we got. So I'm assuming they are a TO220 package. Can you confirm, Josh Hansen, that they are TO220 package? Probably are. Package type TO220. $220, blaze it. Okay, TO220, TO220AB, fucking TO220. Not the Fs. The Fs are closed back, I think. So that'll do. And then we want maximum drain source voltage. So we're looking for something around about the 100 volt mark. So let's choose 100 and let's choose 120 and 150. Nothing wrong with putting higher voltage FETs in. And let's go with, okay, let's see what we've got lined up on here for that. Wow, so there's 292 parts to choose from. Okay, now let's filter out any of the ones that are under the, so we need at least 40 amps, don't we? This is fucking rubbish. 9.7 amps? What's that all about? So you need at least 40 amps, don't you? So let's go down here and let's tick all of the ones which are at least 40 amps. So we're going to go from 40 to, wow, fuck. Okay, let's be realistic now. Let's go from 40 to 100. There's still 100 and something results. Jesus. Okay. Ours is N channel MOSFET as well, so we need to do that. Channel type N. There's only 2 P's anyway. Right. It looks like you look like you're spoiled for choice. You've got a STP 80NF10. Let's go for price. Let's see what the cheaper ones are. Okay, let's see what we've got. So depending how many you need, you could go for a 60NF10 ST Microelectronics. That's an 80 amp 100 volt part. That might work. Let's see what the gate capacitance is and the gate charge and input and all that stuff. So let's have a look at the data sheet. So let's see. Drain source voltage, etc. Yep. 300 watt, that's not too bad. Now, okay, input capacitance. 4270, that's acceptable. It's a little high. Total gate charge, 104, it's acceptable. It's not crazy high, but it's on the higher side. So they might work okay. It's provided your drive circuit is manly enough to drive them, they might work fine. What else do we have? FQP55N10. Let's have a look at these. So these are only 155 watt parts. It doesn't necessarily mean the world. They'll still work. Input capacitance is half that of the other one, and the total gate charge is roughly the same. So maybe they're not the best idea. You could probably get better than that. Yeah, there's literally hundreds of choices, so just go for something that is nice high current, that is relatively good power dissipation. You want to check for a low RDS, so the RDS is usually listed at the top of the data sheet, usually. No, maybe not. Where's the RDS? VGS, VD, DDP. Here we go, RDS. So typical maximum. So you want to go for as low RDS as you can and match that up with a good, nice low input capacitance, which is somewhere around here. So a nice low input capacitance. Generally anything under like 2000 is good. 4000 is okay, it's on the slightly higher side, but provided the drive circuit's manly enough, it should be fine. Gate charge, I've seen gate charges as low as like 40 NC. 104 is again slightly on the high side, but not too high. Just marry these up with a low RDS and a high output current, and you should be fine. Jesse says, still here, just not being chatty. That's cool. Thanks for letting us know you're still here, Jesse. Found you by accident, so I'll subscribe. Thank you very much, Kinky Tiger. I'm still here, still dimpling, just not easy to upload vids out in China, no time. Cool, good to see you're still around, Dennis, man. Dennis wasn't a kid when I was chatting to him. When I was like in my teens, Dennis wasn't a kid, so... Dennis is 40 now. Shit, yeah, okay. I'm 26. Yeah, I'm 26 now. If you get a chance, check out my vid on the Phoenix sub. Phoenix. And if I'm all out of order in the chats, my phone keeps bickering. Oh, no, buffering. No worries, buddy. Yeah, I'll check that out. Hunter Callahan. I'll check that out, buddy. I'd like to see a video of the camera and tools you use and what you would like to change. I could maybe like do a little sweep of my shit now. My tools and my cameras are very, very basic. Like, this is a really fucking budget setup. This is a really budget live stream setup, and it's a mess as well. It's not the tidiest of setups, and it's just really, it's really redneck. So if I steal my scope cam, I can probably give you a little guided tour of what's going on around here. Maybe if my wire's long enough. So over here, let's turn this lamp back on. Right. So over here we have the scope resting on top of my Yamaha powered mixer, my frequency generator. I use this setup for listening to music in the workshop. Yeah. The camera settings are set for the scope, so that's why everything looks dark as shit. So I've got the iNova Pro powering the DD15s in my old JBL boxes. These are coaxial, so the tweeter is behind the dust cap and it's an acoustically transparent dust cap. So I got rid of the original tweeter and mounted a massive fucking slot port, and it sounds amazing. And the tweeters are on the Yamaha, and the mids are on the woofers are on the iNova, and the 80 PRS I'm using that for the active crossover, so that sounds quite nice. And then on the workbench, which is a massive mess at the moment, we've got the bench power supply, which you guys bought through the donations. Thank you very much, on my YouTube channel. Got my massive fucking thing of parts. My computer monitor, my old school piece of crap, really tiny computer monitor. The cameras which I use are just these tiny Logitech webcams. This is what you're looking at me on. These tiny piece of shit little Logitech webcams. Now, you know, they're alright. They cost like £10 each. So I've got like a whole bunch of these. I've got 4 of these now. I've got 2 more coming in the post. This is my Zoom cam, and that's hooked up via HDMI to a capture card. You can see why that's a nightmare to focus and stuff all the time. Dummy loads go here. That's my Dell server power supplies. That's my thermal imaging camera. That's my solder station, my AOUA. So I've got my hot air gun here, which the thing fell off the side, so I just shove it there. And then the soldering iron is on a hook on my lamp stand. It's got a hook that I keep my soldering iron on, so I can just grab that anytime, bring it over to the bench, whack it back on the hook. It's proper fucking redneck. It's like, I've literally just shoved all this stuff together to get working. The plan is to make the workshop beautiful, and really change it up, have like DD banners and have this all really nice, and have like anti-static surface top and everything done properly, but I haven't got around to it yet. So yeah, this is pretty much it. I'm still using my trusty old LGA 775. So yeah, I'm using like 15-year-old hardware. DDR2, a LGA 775, a 560 Ti. So yeah, it's all very, very old school and shit. But I get the job done. It does me fine, gets me by. Now I'm gonna have trouble fucking re-centering this now, aren't I? Right, there we go, that looks good. Details on the scope and power supply. Scope is a HP 54602B. Very nice scope. I picked it up for £150, but I think in the US you can get them for like $120. So really, really good scope. Power supply, the bench power supply is some EPS 20 amp 20 volt power supply, or 16 volt, sorry, yes, 16 volt 20 amp power supply. Just got that from eBay. It was a used power supply. I think they were like £300 brand new, but I got it for really cheap, so that was good. The Dell server power supplies are just Dell server power supplies. They're 175 amp each, and they were like £25 each, like 30 bucks each for those. Does the flow here we go. Corey says, does the flow of electricity alternate as in AC, or does an amp output DC and plus DC? Does the plus side of an amp stay the plus side, and does the negative stay the No, so the amplifier actually outputs a sine wave which oscillates around ground. So the sine wave will rise up to positive voltage, down to ground, and then down into negative voltage. So the positive, like, all amplifiers are different. Most amplifiers, now this is what's called a half bridge amplifier. So the majority of car audio amplifiers are half bridge, which means that the speaker terminals, the positive speaker terminal does all the pushing and pulling. So the positive speaker terminal has the sine wave on it, plus rail, ground, negative rail, ground. And the negative speaker terminal just grounds that signal into the virtual output ground, just acts as to complete the circuit. So yeah, the positive does all the work, does the sine wave into plus and into negative. Some amplifiers, which are called full bridge amplifiers, both the positive and the negative speaker terminal have audio sine wave on them. And they usually actually have half rail voltage DC on them at all times. But because both of the speaker terminals both rise to the same voltage level, the speaker that's connected sees 0 volts because there's 0 volts potential difference. So the way that it drives the speaker is one of the speaker terminals, like the positive, will rise up to positive rail, then creating a potential difference between the two speaker terminals, so the subwoofer moves outwards. And then it will go back down like this. No, it does this. Yeah, it does. Yeah, that's what it does. Sorry, I correct myself. The positive and negative speaker terminals will be out of phase with each other. So when the sine wave builds, the sine wave will do this, and the two speaker terminals, positive and negative, rather than being half rail voltage, one of them will swing to positive rail, the other one will swing to ground. And that creates a huge voltage potential difference. So the speaker goes whoop and moves. And then they go back to ground, and then they do that. And then the speaker moves in the other way. So the speaker moves out, in, or in, out, like this. So that's a full bridge amplifier. That's how it works. Whereas the half bridge amplifier has the negative speaker terminal at ground, the positive speaker terminal also at ground. And the way that works is that one rises up like that and down to ground like that. And that's how the subwoofer moves like that. I know. Sorry, no. It goes below. So it goes above like that and below like that, above like that, and the negative stays at ground like that. So that's a half bridge amplifier. I can't believe I'm doing this on camera. That's half bridge, and full bridge is like that. That's the only way I can explain it on camera like this. That's also why on a full bridge amplifier like a Brazilian amplifier or the Alpine MRP range or the Vibe Monobox, any full bridge amplifier, because when the amplifier is turned on, there's quite a high voltage, actually DC, sitting on both speaker terminals. So if you touch the speaker terminal, even when the amplifier is not playing any music, you touch the speaker terminal and you put your hand on ground, you'll get a you'll get a shock, you get a tingle shock, like 50 volts DC. And also if your speaker wire comes out the sub and touches the vehicle ground, then the amplifier will blow because it will then short out the half rail DC to actual ground and it'll blow the output section. Have you ever used an Xbox 360? I never owned an Xbox 360. I was never into gaming. I'm not really a gamer, so I've never really owned a games console. Like I own a PS3, but I only use it to watch Blu-rays. I mean, okay, I use it to play Gran Turismo sometimes on my projector. I've got a big projector upstairs, a 3D projector, and a Logitech G29. So yeah, I used to use that a lot to play driving games, Gran Turismo, and like WRC rally and shit. But yeah, I've never like had an Xbox or anything like that. Is that a Sound Magus amplifier behind you? Holy fuck, that's well spotted. How the fuck did you get Sound Magus from that? Yes, this is a Sound Magus amplifier. This is a piece of shit. These Sound Magus amplifiers, the build quality is terrible. Like, nothing is seated down properly. The traces are thin as fuck. The board is thin as fuck. The soldering quality is awful. Don't buy these. They're rubbish. Open it up. I've actually repaired this already. Actually, no. These heat sinks are terribly built. This the amplifier case takes like a good 20 minutes to screw back down because the back plate is slightly too wide to fit in the slot. So you have to like screw it down, hammer the other side in, screw that down, then hammer it and screw it. I'm not taking the back off that again. It took me fucking ages to get that back on. I have a Rockford Prime that has 0.685 DC on both speaker terminals, no output. That's a shame. That's bullshit. Those amplifiers are not easy to repair. Actually, Robert, does the amplifier power up with a green light and appear to be working fine? Because those amplifiers, they suffer a lot from snapped inductor leads. So open it up and check the inductor isn't snapped off the board. That might be why you have no output. Lots and lots and lots of Rockford amplifiers that I've looked at, like those ones, the inductors, they snap off the board. So check that first. So is that AC or plus DC and minus DC? It's AC. Yes, AC. Alternating current. Plus and minus DC is what you get on the rails. Yeah. So if you open up an amplifier and you have the positive DC rail and the negative DC rail, so that is what the audio wave swings between. So imagine this is ground. So when the amplifier powers up, the voltage rails go like this. So you end up with like plus 80 volts and minus 80 volts. That's your DC rails. So that is plus DC and minus DC. The audio sine wave then swings between those two. So it swings from ground down to negative rail and up to positive rail. That's your DC. Think of like the DC plus minus is like a little window that the sine wave can oscillate between. And that's why voltage drop is so important, because say you've got an amplifier and when you power it up with 12 volts, the voltage rails go up to plus minus 80 volts, yeah? With 12 volts worth of input. If you then start your engine and you give it 14 volts, now the rail voltages go to 100 volts plus minus. So you've now got 100 volts plus minus for the audio wave to swing between. So if you set your clip point to 100 volts plus and minus, so your audio wave clips bang on plus 100 volts minus 100 volts AC, and then your voltage drops down to 12 volt, all of a sudden it's clipping. And that's why it's called clipping, because it clips off the top of your sine wave. Your sine wave now has a flat top because the sine wave is trying to go above to where 100 volts was, but now your rail voltage has shrunk to 80 volts. So now the sine wave can't go to 100 volts because it's now capped to 80 volts. So it goes up and it goes caps off and down again, which is why you get the flat top to the wave. So yeah, if you want to get the most power out of your amplifier, make sure your voltage is staying at 14 volts as much as you can, and you're going to get the most power out of it. Is it the small inductors in the output section? It's a 4-channel. Ah, Robert, are all 4 channels giving you no output? Because that would not be the inductors. That would be some other issue. So I would, if that's the case, I would be opening up the amplifier, plugging in some RCAs to obviously play a sine wave, and I'd follow the sine wave through the input circuit follow it through the op amps in the input circuit, and try and find where the amplifier loses it. So I'd plug the sine wave in, and I'd probe with my scope the output transistors if it's a class AB. I'd probe the output transistors. If the output transistors have a sine wave on them, but it's not at the speaker terminals, then there's a break in the circuit somewhere between the transistors and the speaker terminals. If the output transistors don't have any sine waves on them for audio, then you need to go back through the drive circuit, just probe each stage back through the circuit and try and find where it loses it. I've seen better days. Against up many ways. I've seen better days. Does anybody remember the lyrics to Basshead Anthem? I was actually quite proud of some of those lyrics in that song, actually. Some of the lyrics in the Basshead Anthem I thought were pretty good. I just can't rap for shit. Like, the Basshead Anthem, the beat is on point, the beat is sick, but I can't rap. I'm white as fuck. I can't rap. So the lyrics, so the vocals are suck on that song, but the lyrics are quite cool. The beat is pretty cool, but why do you like digital design so much? I used to like digital designs a lot, but I've actually lost a bit of respect for digital designs recently. I don't like digital designs the same as what I did a year and a half ago, a couple of years ago. They're pretty good, but I don't know. Quality control is not what it used to be. I actually prefer B2 audio to digital designs now. Have you heard PS Sound's car? Nope. Nope. The only cars that I will have ever heard are cars that are based in the UK, because I live in the UK. So if it's not in the UK, I haven't heard it. What's your vape setup you have there? My vape setup is a Drugger RDA, and it's plugged into my bench power supply. So yeah, I'm vaping off my bench power supply, which you can see here. So this wire just goes into the bench power supply here. So when I want to vape, I turn the power supply on. I don't have a mod. Well, I do have a mod, but it's shit, so I just vape off my bench power supply. Remember the Oh My God Usher rebase? Yeah, that was pretty cool. That was nice. Damn Good Box was funny as well. I had a DD 17-inch Beast. Yeah, the DD 17-inch Beast, it was actually an 18, but they called it the 9917. That was a good woofer. That was when that was in DD's prime time. But their quality control has gone downhill since they got really big. Demand has gone up and quality has gone down. We don't have Crossfire in the UK either, so I've never seen any of that stuff. Is there a way to extend the clip light on a Bandit amplifier remote? Yes. Use an optical cable. Ta-da! You've not got to do any soldering. You've not got to connect it to the circuit board. If you use optical fiber cable, then somehow attach it to top of the amplifier, like shove some optical fiber cable into the clip LED area, so that it passes the light through the cable. Run the long optical fiber up to the dash, and then put a diffuser on the end so that you can see the LED up the front on your dash. And hey presto, no electricity, no wiring involved. You're just taking the light source up to the dash. No voided warranty either. Yeah. You'd have to play around to get it right. Like in my head, there's like duct tape, but obviously you know there's better ways of doing it than that. Like somehow attaching some optical fiber to the thing in a nice way that looked pretty, without like duct taping it there or something. Or like if you weren't worried about the visuals, you could like use some hot glue. Yeah. B2 audio gets smelly. Nah, B2 audio is fucking great stuff. Everything gets stank. If you push it enough. Sundown gets stank if you push it hard enough. The only subs that don't get stank are the superconductive voice coil Omega 40Ks. They will never get stank because they're superconductive, so they don't get hot. DD never made any amplifiers. They just went to a factory and put their sticker on some amps. I don't believe that DD have never actually commissioned any engineers to design them an amplifier from scratch. As far as I'm aware, as far as I'm aware, no engineers have ever worked for DD that have designed amplifiers from scratch, like JL Audio, Rockford, MTX, Alpine. Yeah. All those brands have their own amplifier boards that no other brand has. But all the DD amps, they share their circuit designs and their circuit boards with many other brands because they are a factory standard board, as I believe. I could be chatting shit, but yeah. I live about a mile away from DD. Cool. What's the worst smelling speaker or amp that you have? I got a fucking stank-ass Hyphonics, and the reason it smells is because the owner is dirty, is horrible. This is a really nasty, skanky guy, and he had the amplifier under his bed in his bedroom for like fucking years, and he was like, "Yeah, can you fix this?" And I like the actual amp itself is dirty and it stinks. Like, I don't want to work on that shit. Like, I'll put it out in the garden, fucking hose it down and let it dry before I work on it, you know? Is LW Audio still going in the UK? Provided I can make another order from Xenon, yes. I'm working on it at the moment, but they want a shitload of order quantities. I'm trying to work on it. Ah, yes, fucking JBL Crown amps. They're some of the best. So out of the Brazilian amplifiers, which are the most efficient? They're all about the same. Like, people think Brazilian amplifiers are crazy more efficient than Koreans, but they're not. They're not actually that more efficient. Like, it's the same Class D technology as Korean amplifiers, but it's just a full bridge design using modern MOSFET parts. So it might be a little bit more efficient because the MOSFETs they're using are lower RDS, and so they don't get as hot, don't require as much current to do power. But it's nothing crazy. Like, people say, oh yeah, the Brazilian amplifiers are like 90%. No, they're not. They're pretty much the same as a Korean amplifier in terms of efficiency. You might get like maybe 3 to 4, maybe 5% more efficiency compared to a really old Korean, compared to a really new, well-designed Brazilian. But they're nothing to be shouting about in terms of efficiency. They're just small and using modern MOSFET technology and using fast switching frequencies and full bridge design. That's all it is. All done the repair. Yeah, I'm done repairing for this evening. I've blown up some FETs and this one's getting hot and I can't be bothered anymore. Tomorrow. No, Monday. Tomorrow I'm busy. Sunday I'm chilling. Monday we'll carry on. Right, I think it's about time I went to bed. It's almost 3 AM here in the UK. I need to get some sleep. I need a drink as well. Can you explain why the Alpine X Power mono amps make more power at 2 ohm than they do 1 ohm? Yes, those amplifiers are very clever circuit design. What they do is they are constantly monitoring the current output of the amplifier of the output section. So if you think about the amplifier, technically if it wasn't current limited, it would do more power at 1 ohm than it would 2 ohm because there's more current path for the power to flow down. But the amplifier monitors the current, and if it exceeds a certain current limit, it reduces the rail voltage down in order to prevent there being extra damage. So if you think about like power being voltage times current, if you wire it to 1 ohm, then it's constantly lowering the rail voltage so that the amplifier doesn't overdo itself. If you lower the voltage, you lower the power, you lower the stress on the amplifier. So the Alpine will have like this much rail voltage for its 2 ohm operation. So when you're driving at 2 ohm, it might have like plus minus 70 volts, for example. I don't know, this is an example. Plus minus 70 volts at 2 ohm. When you run it at 1 ohm, it might only be plus minus 50 volts. And then obviously, it'll be lowering the rail voltage to 50 volts to try and accommodate the extra current and not explode. So its sweet spot for the amplifier is 2 ohm with a high rail voltage, and that will equate to the most power. Cool, nice one. Yeah, it's been a pretty nice little live stream. It's a pretty quiet live stream. Actually, we're back up at 40 viewers, which we were down at like 30 viewers earlier, but yeah. Yeah, cheers for tuning in and getting involved in the little audio chat. One last thing, what's the highest rail voltage in an amp that isn't a prototype? Wasn't a JBL like 320 volts? Not sure, haven't worked on that one. The highest rail voltage I've ever seen was in the this amplifier. This is a Taram's 15K, and I think the rail voltage is so high that I can't actually read it on my scope because my probes are times 10. So I would need a times 100 probe in order to read the rail voltage on that, but I think it was somewhere up at like 270 volts. It might even be higher than that with like a 15 volt input. But yeah, Taram's 15K, very, very high. Actually, yeah, fuck. Probably the highest one is like if Taramps do a 2 ohm version of the 15K, that'll be near on 420 volts of rail voltage. Yeah, scary stuff. Right, cool. I'm going to hit the sack. Thank you very much for joining in with the live stream, guys. I'll probably see you next week when we tackle the rest of this shit that keeps exploding, and hopefully I have some good luck next week. So yeah, cheers. And have a good evening and have a good weekend.